All right. Hello, everybody. We are going to cover 1.4 rational expressions in this video. All right, so take notes. 1.4 rational expressions. Again, a bit of a delay on my end here. Okay. All right. So keyword here in rational ratio. So ratio meaning like fraction. Okay. So before we get into rational expressions, let's take a look at regular numerical fractions. And because a lot of the concepts that we see in the process for simplifying, multiplying, dividing, adding, and subtracting numerical fractions, we will be applying those ideas here to rational expressions. Okay, so before we get into rational expressions, let's just kind of recall regular numerical fractions. Okay. All right, so let's take a look at simplifying. Okay, so if you remember with simplifying fractions like this, let's suppose that we have 18 over 27. Okay, so here we can reduce this fraction because what number do they have in common? They have 9 in common, right? 18, 27, they're both divisible by 9. So what I'm going to do here is show you how this works so that you can see the comparison between this and when we do rational expressions. So here what I'm going to do is I'm going to factor 18 as 9 times 2. I'm going to factor the 27 as 9 times 3. Okay. So normally with these numerical fractions, you wouldn't even do this. You would just kind of do it in your head. Oh, 18 and 27, they have 9 in common. And so you would say, okay, so final answer is 2/3. Okay. And it's easier to do that in your head when you have numerical fractions. But when you start dealing with rational expressions, when we start factoring and all of that, it's hard to hold all of that information in our heads. So what we're going to be doing is, instead of skipping this part or doing that part in our heads, we're actually going to write this out where we factor. So 18 we factored it out as 9 times 2, and 27 we factored out as 9 times 3, and we crossed out that common factor that we knew from the very beginning, which was 9. Okay, so simplifying will work the same way. Multiplying, so let's take a look at how we multiply regular numerical fractions. So multiplying, let's suppose that we have 12 over 15 times 25 over 4. Okay, so suppose that we have to do this multiplication. So maybe you remember that we can cross cancel. So like the 12 and 4, because they have a 4 in common, we could do that. But you can also cross cancel up and down. 12 and 15, they have 3 in common. Okay, so pretty much anything in the numerators can cancel out with anything in the denominators. Okay. All right. So if you notice that 12 and 4 have 4 in common, then let's go ahead and factor out the 12 as 4 times 3. And we'll just use the 4 times 1 for the bottom, because you guys said that 4 is what they have in common. Between the 15 and 25, they have what in common? 5. Okay, so hopefully you said 5. So then I will rewrite this using 5 times 5 and 5 times 3. Okay, so some of you guys might be thinking, oh, well, this seems a lot more complicated. I just cross cancel. And that's fine. Like I said, you would normally do that with numerical fractions, but I'm showing you this extra step right here where we do factor it, because that's what you're going to be doing when we look at rational expressions. Okay, you're going to be doing this factoring part, and then you cancel the common factor. So we have 5 there and 5 here that we can cancel with. And then we also see that we have the 3 and the 3. So it's not that you have to go diagonal all the time. You can go top and bottom. Okay. And then what we have left in the numerator is just 5. And in the denominator, we have 1. So our answer is 5 over 1, which simplifies to just 5. Okay. All right, so that's multiplying. We are going to be using this exact same process when we look at rational expressions. Okay, so basically we are going to start off with this problem, and then we will factor, and then we'll cross out any common factors, and then be done. Okay, let's take a look at division. So with dividing fractions, hopefully you remember that when you have division of fractions, so like this one, 8 over 15 divided by, let's do 14 over 27. Okay, so if you're dividing fractions, hopefully you remember that we actually will keep this first one. I call it KFC to help the students remember. We keep this first one. We flip this one, the second one. Okay, and we change this multiplication. Okay, so we change the division to multiplication. Okay, so KFC. All right, so we're going to keep this as 8 over 15. We keep that. We flip 27 over 14, and we change to multiplication. Okay, so hopefully you remember that about dividing fractions. And then here, now we just treat it like the problem above. We look for common factors and cancel. Okay, so 8 and 14, they have 2 in common. So let's go ahead and factor that as 2 times 4. And the 14, let's do 2 times 7. Okay. And then the 15 and the 27, they have 3 in common. So let's rewrite those as 3 times 9 and 3 times 5. Okay. And so then here, now we can go ahead and cancel out the common factors. So 2 and 2, and then also 3 and 3. Okay. All right, so nothing else cancels. The 4 doesn't cancel. There's nothing to cancel with the 5 or the 7. Same thing with 9. There's nothing that 9 can cancel with 5 and 7. So here, multiply across the top, that's 36. And multiply across the denominators, and we get 35. Okay, and I'm perfectly fine if you leave this as an improper fraction on the test. However, when you do the homework, use whatever it is that they want you to use, which is going to be important when you take the test. Make sure you do the homework so you know how they want you to answer the question, or how they want you to input the answer, because the test will also be online. And if you put 36 over 35, they might ding you for that if you don't change that to mixed number 1 and 1 over 35. Okay, so So that's how you do numerical fractions. So let's go ahead and take a look at um, rational expressions. So now with rational expressions. Okay. So let's take a look at simplifying first. Okay, so a lot of factoring that will be going on here. So if you feel like you're a little bit weak with factoring, then you might want to go online and find some factoring problems to do, or email me or message me asking me to provide you with some more resources on factoring. Okay, so let's take a look at this example. Suppose that we have to simplify this problem. X squared minus 1 all over x squared plus x minus 2. Okay. Okay, so the first thing you want to do is factor first. Okay, so let's go ahead and do that. So the numerator, we have x squared minus 1. So hopefully you all recognize that as difference of squares. So if we have difference of squares, that's always going to factor out as x plus 1, x minus 1. Okay. And then the denominator, when we factor that one out, so let me move this up. Okay, so when we factor the denominator, we're trying to figure out what times what to make x squared. So that would have to be x times x to make x squared. Okay. So x times x to make x squared. Okay, so over here, now we need to make -2. So we know that the signs have to be different in order to make negative. Okay, if they're the same, positive, positive, we get +2. If they're both the same, negative, negative, we also get +2. But we see here, we want -2. So what times what is -2? That would have to be 2 times -1. And of course, you want to make sure that you get positive x for the middle term. So multiply that all out, and you should get these three terms here, x squared plus x minus 2. One way to check, we definitely get the x squared. X times x is x squared. We definitely get the -2. +2 times -1 is -2. But do we get +1x for the middle? The way you check, do this outside product. Okay, when you take that outside product, okay, we get -1x. And you should be able to do this in your head, but I'll do it off to the side. -x. And then this inside product is +2x. And then, so we got that +2x from right here, multiplying these two inner ones. Okay, so combining these, -1x and +2x will give me +1x, which is exactly what we need because that matches with this. Okay, so you need to make sure that you factor correctly. All right, once you've factored everything correctly, then you can cancel out common factors here, x minus 1 with x minus 1. And your final answer is x plus 1 over x plus 2. Okay, so again, if you're struggling with factoring, then stop the video because the rest of it will seem confusing if you're not strong with factoring. Okay, stop this video and watch the video on factoring that I provide um, on Canvas. Okay, so that's simplifying. Let's take a look at multiplying and dividing. Okay, so let's do multiplication first. Okay, so let's take a look at that with this example. Okay, so example 1, suppose that I have this x squared plus 2x minus 3 over x squared plus 8x plus 16. Okay, and suppose that I'm going to multiply that with 3x plus 12 over x minus 1. Okay, so again, the first thing you want to do is factor first. Okay, so let's go ahead and do that. Okay, so that first numerator, that's going to be similar to the last one where we have these double parentheses. So x times x to make x squared, we need to make negative 3. So we need a positive and a negative. And we're going to use 3 and 1. The 3 needs to be positive, and the 1 needs to be negative. Okay? And then let's do the denominator. So again, that one's going to be our double parentheses. So what times what to make x squared? That is going to be x times x. Okay. And we want to make positive 16 and positive 8. So we're going to have both of these positive. All right. So 16. A few different ways to make 16. We can do 1 times 16. We can do 2 times 8. We can do 4 times 4. Which of those do you think will give us the 8 in the middle? Hopefully you said 4 times 4. Okay, good. And then up here in this second numerator. Okay, so this one here, this is going to be one of those GCF kind of factoring where you take a look at them and you see what they have in common. So they both have 3 in common. So I'm going to factor out a 3 and I will be left with x plus 4. Okay. And then down below, that is just going to be x minus 1. Okay, so once you go through the process of factoring everything first, like we just did, then you can go ahead and start canceling. So what can we cancel here? X plus 4 with x, one of these. It doesn't matter which one, but it only cancels out with 1. Okay, and then the x minus 1 with the x minus 1. Okay, and we see there's nothing left to factor or cancel. So my final answer is in the numerator, we will have 3 times x plus 3. And in the denominator, we will have x plus 4. And this here would be our final answer. Okay. All right. So that's a multiplication problem. So again, the first thing you do is factor, cancel out common factors. And then let's take a look at division. All right, so let's take a look at this example, x minus 4 over x squared minus 4 divided by x squared minus 3x minus 4 all over x squared plus 5x plus 6. Okay, so again, the first thing you want to do is factor. Okay, so x minus 4, nothing to factor there. Down below in the denominator, x squared minus 4, we have perfect squares. So this is going to be x plus 2, x minus 2. Okay. And then remember, we're going to change this to multiplication. And we're going to take the reciprocal of the second one. So I'm going to factor the denominator. And I'm going to put it right here. And then I'm going to factor the numerator. And that is going to go down below. Okay, so we have to flip this one. All right, so factoring out that denominator. So we get x times x to make x squared. We want positive 6 and positive 5, so we're going to have both of these positive. And we can do 1 times 6, 2 times 3. So which of those will give us 5? 2 times 3. Okay. So that's the denominator that moves to the numerator. Now let's factor out that numerator. Okay, so x times x to make x squared. We want negative 4, so we know one of these will be positive and the other one will be negative. And we can do 1 times 4 or 2 times 2. Which of these will give us a negative 3? The 1 times 4. Okay, so we need the 4 to be negative, and we need the 1 to be positive in order to get negative 3. Okay. All right, so once you have all of your factors, then you can go ahead and cancel. So x plus 2, those guys can cancel. And x minus 4, these guys cancel. And it doesn't look like there's anything left. So if there's nothing left, then let's just go ahead and copy the x plus 3 in the numerator. And down below, we will have x minus 2 and x plus 1. Okay, so that would be our final answer. Okay, so that is simplifying, multiplying, and dividing. So all three of those, they are basically the same process. You factor first and you cancel any common factors. That's pretty much it. Okay, so this next part that we're going to look at is adding and subtracting fractions. Okay, so let's take a look. All right, so before we get into adding and subtracting rational expressions, let's go back to numerical fractions. So let's recall regular fractions. Okay, so if you remember when you were adding or subtracting numerical fractions, we needed like denominators. Okay. So for example, if you were adding these two fractions, 2 over 9 plus 1 over 6, Okay, so these two fractions don't have the same denominator, so we wouldn't be able to add them right now. So we would need to find the LCD. And so the LCD between these denominators, 9 and 6, would be 18. Okay. All right, so the LCD is 18. So then that means we need to turn these into similar fractions where their denominators are 18. Okay, so let me change colors here. All right, so over here, all right, so in order to turn that 9 into 18, I would need to multiply it by 2. But you can't just multiply the 9 by 2 because then you change the value of 2 over 9. So what you're going to do is you're going to multiply by the number 1 because anything times 1 is itself. You don't change its value, right? So you're going to multiply by 1, but 1 written in the form of 2 over 2. Okay, so this way you get your 18 in the denominator, and then you get 4 up here in the numerator. And then same thing with the 1/6. So in order for that 6 to turn into 18, we need to multiply it by 3. But again, you can't just multiply by 3 because then you change the value. So you're going to multiply 1 over 6 by 3 over 3. Okay, that way you get the 18 on the bottom and you get 3 on top. Okay. All right, so now that they have the same, oops. Okay, so now that they have the same denominator, we can go ahead and add these. So 4 plus 3, that is 7 over 18. Okay. So what we do here is basically what we're going to have to do with rational expressions, except that here it's very easy to identify the LCD. When we do it for the rational expressions, it's a little trickier. Okay, so let me write down the steps on how you can identify the LCD. Okay, so identify the LCD. The first thing that you're going to do is you're going to factor your denominators completely. Okay, so factor denominators completely. And use exponents if possible. And you'll see why in a minute. So like if you have x plus 4 times x plus 4, don't leave it like that. You want to write it as x plus 4 quantity squared. Okay? So use exponents if possible. Okay, number 2, list all the bases present. List all bases present, but do not repeat them. If they appear more than once. And I'll explain why when we're going over it. Okay, but it has something to do with this third step here. Let me wait for this to load. Okay, so this third step here, use the highest exponent. Use the highest exponent present for each base. Okay. All right, so I'll do an example so that you can follow these. So let's take a look at these steps again. So we start off, we factor all the denominators, right? Factor them, just the denominators. Don't worry about the numerators. We factor all the denominators completely. Use exponents if possible. Then we're going to list all the bases present. No need to repeat them if you see it more than once. And then we're going to use the highest exponent present for each base. Okay, so let's take a look. All right, so find the LCD. All right, suppose that we have this expression here, 1 over x plus 2 plus 2 over x plus 2 squared x plus 3 minus 3 over x plus 3. Okay, so here I have it already factored for you guys, so no need to do the factoring. So we can jump to step 2, which says to list all the bases present. Okay, so your LCD is going to be made up of all the bases present. So we see that we have an x plus 2. So we're going to need an x plus 2 in our LCD. And we also see x plus 3. So these are the bases that are present, correct? Okay, x plus 2 and x plus 3 are the bases that are present. Okay, so then those are going to be the bases in your LCD. Okay, so now that we have that, we can jump to step 3. Use the highest exponent present for each base. Okay, so let's start with the x plus 2. When we look here at the original problem, we see we have an x plus 2 to the first power, and we see that we have an x plus 2 to the second power. So the highest power that we see here is 2. So here in our LCD, x plus 2 will have a power of 2. When we look at x plus 3, we see that we have x plus 3 to the first and x plus 3 to the first. So in our LCD, x plus 3 will have an exponent of 1. Okay, do you see how that works? X plus 2 to the first versus x plus 2 to the second. Okay, you take the one that has the higher exponent. Just because you see 2 of these here, x plus 3 and x plus 3, doesn't mean that you're going to use an exponent of 2. If you don't see an exponent of 2 on the base x plus 3, then it will not have an exponent of 2. Okay? All right, let's take a look at this one. Let's find the LCD. Okay, so let's find the LCD of this problem. 1 over x squared minus 4 plus 1 over x squared plus 4x plus 4 plus 1 over x squared plus x minus 6. Okay, so here, that's supposed to look like a 4, but it doesn't. Let me fix that. If I can. All right. All right. And x squared plus 4x plus 4. Okay, so we need to factor all of the denominators first. Okay, so this first one factors out to x squared, x plus 2, x minus 2. The second denominator factors out as, let's see, x. We need positive and positive, and we need 2 and 2. Okay, so we see here this is x plus 2, x plus 2. Okay, so this is what we mean by, okay, use exponents if possible. So here, don't leave it like that because our LCD depends on these exponents. So use the exponent if you have repeated factors. Okay. And then this one over here, x times x to make x squared. 1 positive, 1 negative. And we can do 1 and 6 or 3 and 2. And it looks like 3 times 2 is the winner. Okay, so when we do our LCD here, we see that we are going to need all the bases. Let's see what bases are being used. We need an x plus 2. We need an x minus 2. And we need an x plus 3. Are there any other bases? X plus 2, x minus 2, x plus 2, x plus 3, and that has an x minus 2, which is already here. Okay, so these are all the bases that are used. What's the highest exponent for x plus 2 that we see? Square. So that will get a square. What about for x minus 2? Highest exponent is 1, so nothing there. X plus 3, highest exponent is 1, so we leave it. So this here would be your LCD. Okay. All right. So hopefully you understand how to find the LCD now. If not, again, just message me and I can go over some examples for you. Okay. So let's go ahead and take a look at how to actually add and subtract. Okay. So add, subtract. Okay, so let's do this first example here. All right, let's do 3 over x minus 1 plus x over x plus 2. Okay, so no need to factor these, right? Okay, so our LCD is basically going to be x minus 1, x plus 2. Okay, so x minus 1, x plus 2. This is our LCD. So this is what we want our denominators to look like. Okay, so clearly right now they do not. Okay, so, but we want them to. We want them to look like this. Okay, so we want them to look like that. All right, so just like with numerical fractions, we need to figure out what we need to multiply by so that it looks like that. Okay, so all right, so taking a look at this one over here, x minus 1, this first fraction, which has x minus 1, but we want it to look like the LCD, x minus 1, x plus 2. So we need to multiply this by x plus 2. But remember, we have to multiply by x plus 2 over x plus 2, or else we change the value. Okay? And now that denominator will look like our LCD. Okay? And that numerator will now look like this, 3 times x plus 2. Okay, that second fraction has x plus 2, but we want it to look like x minus 1 times x plus 2. So we need to multiply this by x minus 1. Okay, but again, you can't just multiply it by x minus 1. You need to multiply by x minus 1 over x minus 1. Waiting for it. There it is. Okay. So when you multiply the bottom, you get your LCD. And then that numerator is going to have to be this, x times x minus 1. Okay. All right. So let's go ahead and let me get back my black pen. All right. So let's go ahead and multiply out those numerators. So here we get 3x plus 6 over x minus 1, x plus 2, plus, and here we get x times x, so that's x squared minus x all over x minus 1, x plus 2. Okay, so now they have the same denominator, so now we can go ahead and add these fractions together. So we can go ahead and combine like terms in the numerator. So I'm going to go ahead and put them in descending order. So I'm going to start with x squared. We only have the 1, so it's x squared. Now I'll combine my x's. We have a 3x and a minus 1x. 3 minus 1 is 2x. Okay, so I get x squared plus 2x. And then I have just the one constant there, 6. So I'll put that down. X squared plus 2x plus 6. Okay, and then our numerator will remain our denominator will remain x minus 1, x plus 2. Okay, so x minus 1, x plus 2. And whenever you get your final answer like this, you always want to check to see if that numerator can factor out and if any of its factors can cancel with x minus 1 or x plus 2. Okay, because you still want to simplify. Okay, but I already know x squared plus 2x plus 6 won't factor into anything with x minus 1, x plus 2. So this is the final answer. Okay. All right, so that is pretty much it. So you basically have to factor and come up with your LCD. And again, your LCD will be made up of the bases and the highest exponent on them. And then when you figure out what your LCD is, that's what your denominators should look like. And then you can figure out what you need to multiply each fraction by once you know what you're missing. Okay. Again, if you have any questions, just message me or text me.